The United States consumes approximately 3 million tons of polyethylene terephthalate, also known as PET, per year. This accounts for about 8% of the 37 million tons of plastics consumed by the U.S. yearly. PET is used in many applications, including the production of soft drink bottles, food containers, and clothing.
PET, plastic code number 1, is one of only 2 recyclable plastics in production. Only 2% of plastics are actually recycled, so the remaining 98% are incinerated, sent to a landfill, or leaked into the environment, so we can see that using processes to manage the growing quantity of plastics is absolutely necessary. Current PET recycling technology generally requires high-quality plastic waste feedstock, meaning it can't handle contaminants like food residue or dye. PET fibers, which are used in clothing for polyester, are also incompatible with current recycling processes, causing even less post-consumer PET to actually be recycled.
Currently, the main method of recycling PET is through mechanical processes. Mechanical recycling begins with PET that has already been sorted at a materials recovery facility in order to enter as few contaminants into the process as possible. Impurities like labels and bottle caps still remain though, so they have to be removed. Mechanical recycling technology can primarily process rigid PET into recycled PET, or rPET. This is suitable for food containers, polyesters, carpet and clothing fibers, and films. It can't, however, break down other post-consumer PET waste. Neither can it handle low-grade feedstocks with contaminants. Thorough sorting of the PET feedstock requires extra stages in the recycling process, which makes it even more cost and time intensive. Every time the PET is used in the recycling process, its physical properties also change. This poses another hurdle to effective mechanical recycling because repeatedly processing the PET via mechanical means causes the resulting rPET to be brittle and less useful for downstream applications.
Chemolytic recycling is a category of chemical recycling of PET that involves breaking the PET down into its monomers, which together form the PET polymer. Chemolysis involves using a solvent, which is a solution that can dissolve other substances. PET can be broken down by a variety of solvents, including water, alcohols, and acids. The 5 main methods of PET chemolysis are hydrolysis, aminolysis, ammonolysis, methanolysis, and glycolysis. While those names might sound pretty complicated, they just refer to the specific solvent used in that category of chemolysis. The products of PET chemolysis are some form of PET monomer or group of monomers. These low molecular weight monomers can then be purified and reused as raw materials to produce high-quality rPET and other chemical products. Chemolytic recycling of PET has gained a lot of research attention in recent years since it typically involves low waste production and can produce high-quality PET monomers. However, these processes have not made commercialization progress compared to mechanical recycling due to high investment costs and further required developmental research.